Today on How It's Made: carpets, drinking water, laser eye surgery, and acoustic guitars. People use the words rug and carpet interchangeably, but they're not the same thing. A rug covers just part of the floor. A carpet goes wall to wall. Today, most carpets on the market are made of synthetic materials. The first step is to make the carpet yarn. They start by feeding bales of nylon or polyester fiber into the opening and blending machine. The carding machine then untangles the individual fibers, lining them up in neat rows, then gathering them into wider bands. The bands go into cans. From the cans, they go into a machine called a drawing frame, which draws out 5 threads to make one rough, loose thread. That thread goes on to spools. Then they twist threads from 2 spools to make a stronger and thicker thread. Next, they twist 2 of those threads together to form a 2-ply yarn. To ensure the 2 plies don't untwist, the yarn goes through a heat-setting machine at 132 degrees Celsius. The continuous heat permanently sets it, much the way a curling iron sets hair. After 45 seconds of heat setting, the yarn is rewound on spools. Those spools then go to the tufting department, where the carpet making begins. A standard 144-inch wide carpet is made from 1,440 spools of yarn. Each spool feeds into a plastic tube, which feeds into the tufting machine, where the 1,440 lines of yarn feed 1,440 tufting needles. The needles stitch the yarn into a canvas backing made of polypropylene. With slow motion, you can see the yarn being hooked onto the canvas, then cut underneath into carpet pile. Up to 12 needles work each inch of canvas. The result is a pile carpet in the standard 12-foot width. Next, they dye it. For multicolored carpets, they use a machine called a chromajet. It works much the way a computer inkjet printer does, forcing streams of dye in different colors into the carpet fibers. The more complicated and colorful the design, the more often the machine passes over the carpet. For solid color dyeing, there's a mixer in each dye reservoir to keep the color even. They soak the carpet for 4 hours in a hot bath of dye and water, heated to 100 degrees Celsius. Another method uses heat and air pressure in an autoclave. What the bath method does in 4 hours, this method does in just 30 minutes, and with more carpets at a time. Once the dyeing is finished, they apply a water-based glue to a polypropylene backing. Then put the backing over the original canvas backing, locking the carpet fibers in place. Then it's onto what's called the marriage roll, a roller press that marries the 2 backings together. After a quick run through an oven to make the water and the glue evaporate, they cut the finished carpet into rolls. A standard roll is 30.5 meters long. Canadian researchers have invented a pollution-free car that runs on hydrogen. The research team modified the standard car engine to burn hydrogen instead of gasoline. Now they have to figure out how to prevent the hydrogen tank from blowing up in a collision. Drinking water that's fresh, clean, and crystal clear is something many of us take for granted. We might not give it a second thought, but between the source and our tap, a lot happens to make that water fit to drink. Our water may come from Mother Nature, but it's far from pristine. It starts its journey to the treatment plant through a water intake pipe. On the wall of that pipe, about 2 meters down, is a 15-centimeter hole. Covering that hole is a metal grill designed to keep out large debris such as tree branches. The water flows to a pumping station where it goes through a preliminary screening. A giant revolving screen removes fish, garbage, and grass. Once they remove the debris, a low-pressure pump moves the water into the treatment plant. The untreated water, called raw water, is dirty and smelly. So they first add a powerful form of the chemical element carbon, called activated carbon. It absorbs contaminants such as solvents and pesticides. That rids the water of bad taste and odor. From there, the water then goes through a series of mixing tanks. The first tank holds a chemical called aluminum sulfate. It acts as a coagulant, a substance that thickens liquid into globs. In the raw water, the aluminum sulfate forms tiny sticky globs called flocks. Bacteria, mud, and other impurities stick to those flocks. Then the flock-filled water moves on to the second mixing tank. The second tank holds a chemical called polymer, which is essential to the next step of the process, called sedimentation. 5 pipes inject the water with superfine particles of sand called microsand. The polymer coats the sand, making it sticky. The grains of sand then stick to the flocks in the raw water, weighing them down even more. The water then flows into a settling tank where the flocks, because they're heavier, settle to the bottom. You can see the result in this demonstration. The water is finally clear, but it's far from drinkable because it's still full of bacteria, viruses, and other organic matter. So on to the next step, filtration. The water flows onto the top of the filter, then trickles downward, passing through a layer of anthracite, a type of coal, then through a layer of sand. This filters out any remaining particles, which then flow to the middle. But the water is still teeming with bacteria and viruses, so it has to be disinfected. They add 1.9 milligrams of chlorine per liter of water, enough to kill off those germs and bugs. They add a mineral called silicate to prevent calcium buildup from blocking our water pipes. The treatment plant sends water samples to government inspectors who continuously monitor the water supply to ensure it meets safety standards. The amount of chlorine remaining in our drinking water is 0.6 milligrams per liter. The chlorine gas the plant uses is highly toxic. Should any leak out, emergency teams would have to evacuate a 10-kilometer radius. So the plant stores the drums of chlorine in a high-security area. It's taken about 45 minutes to turn raw water into treated water. Now these electric motors will pump it through underground pipes right to your tap. Short-sightedness, far-sightedness, and astigmatism are all due to light not focusing precisely onto the retina. Surgeons can correct this by using a laser to reshape the curvature of the front surface of the eye, called the cornea. The surgeon operates on one eye at a time. He cleans the eye, the lid, and the lashes with antiseptic, and administers anesthetic drops to freeze the eye and lid. He opens the lid wide with a speculum, then rinses the eye with a saline solution. Everything's frozen so the patient doesn't feel a thing. Next, antibiotic drops to prevent infection. Before every operation, the surgeon tests the equipment. He fires the laser on a metal plate to test its energy level. The surgeon administers a few more anesthetic drops, then inspects the microkeratome, the device he'll use to lift a very thin layer from the outer surface of the eye. He also measures the patient's cornea using an ultrasonic instrument. The cornea must be a minimum thickness for it to be safely reshaped. The surgeon uses the speculum again to prop the lid open. Then he begins the operation. He marks the eye with sterile ink, reference marks he'll use later. Next, he positions a metal ring around the cornea. The ring is attached to a suction pump so it clings to the eye. Like holding a tomato steady while you slice it, it holds the eye steady while the surgeon cuts the tissue. The surgeon lubricates the eye with sterile water, then mops up the excess water with a small absorbent sponge. Then he takes the microkeratome and slips it into grooves in the metal suction ring. In a matter of seconds, the device moves across the eye, cutting open a flap of tissue, the same way a carpenter's plane shaves a layer of wood. The surgeon uses a sterile sponge ring to keep tears from contaminating the cornea. He folds back the flap of tissue, exposing the cornea. He mops up the excess liquid, then starts up the laser. Meanwhile, a tiny sponge keeps the flap moist. The laser, an invisible light, fires in pulses, 50 pulses per second. Each pulse vaporizes a 1/4 micron of corneal tissue. The laser has been computer programmed beforehand, so it knows exactly how to reshape the cornea to give most patients 20/20 vision. In less than a minute, it's done. The surgeon removes the sponge and then, using those little ink marks he made earlier as reference points, folds the flap back to its original position. If the flap isn't precisely where it was before, the patient will have distorted vision. Using a syringe that flushes the area with sterile water, the surgeon carefully smooths the flap, the same way you'd smooth out a tablecloth. Then he removes the sponge ring. Within 45 seconds, the negative pressure inside the cornea sucks the flap back on. The flap literally seals itself. With the sponge, the surgeon dabs up any excess water. He applies antibiotic drops as a preventive measure, then inspects the microkeratome again before moving on to the other eye. He takes the speculum off, tapes the eye closed, then performs the same operation on the other eye. When that's done, the surgeon uses a high-powered microscope to make sure the flaps are wrinkle-free. The patient wears protection shields until the next morning, then overnight for a week. The best guitars come from trees about 800 years old, trees with enough rings in their trunks to provide wood with a tight and straight grain, wood flexible enough to vibrate, yet strong enough to withstand the pull of the guitar strings. The guitar traveled from North Africa to Europe with the Moors, who invaded Spain in the 8th century. In time, the guitar became the signature instrument of Spanish flamenco music and the trademark of the singing cowboy. In the 1930s, the acoustic guitar debuted as a jazz instrument. By the 1960s, as the electric guitar took over rock and roll, the acoustic guitar remained a staple of the folk music scene. They use spruce or cedar because those woods are lightweight and vibrate well. Using a 30-ton press that works like a cookie cutter, they punch out the shape of the guitar. The size of the sound hole affects how the guitar will sound. The larger the hole, the more treble. The smaller the hole, the more bass. Then they glue on a wood inlay decoration called a rosette. Next, they make the sides of the guitar. They first immerse wood pieces in boiling water for about 15 seconds. Then place them in a heated press to make the curve. The press applies heat from both the top and the bottom for about a minute. Then they connect the two sides with blocks of wood made of either mahogany or poplar. One is glued and clamped at the bottom, the other at the top. Then they glue on and clamp a wooden lining which will connect the sides to the top and back. Those little cuts give it flexibility around the curves. Then with a hand router, they carefully notch the lining to receive 4 wooden braces to support the back of the guitar. Strategically placed braces help the top of the guitar withstand the tension of the strings. They also equalize sound frequencies by controlling vibration differently at different spots. After a vacuum press makes the bracing adhere evenly, they glue on the top and bottom. The body of the guitar is now assembled. It goes into a press, then a drying rack for several hours. Next, they glue on a plastic binding to protect the guitar's edges. Then comes a fine sanding. Next, a machine with a special sensor measures the precise angle at which the body and neck of the guitar will later be attached. The angle is critical for sound quality. It drills the holes and sands the pieces accordingly. Next, they apply lacquer, 4 to 8 coats depending on the finish. The fingerboard is made of rosewood or ebony. The metal frets separate the halftones on the musical scale. An adjustable rod goes inside the neck. This lets the neck adapt to the different tensions that different types of strings require. They glue the fingerboard on the neck, then vacuum press it to make sure it adheres evenly. Next, they install the machine heads on which the strings will be wound. The rod in the neck slips into a groove on the body. The neck is then bolted and clamped until the glue dries. Next, they glue on the bridge, securing it with temporary screws and a clamp. Then they glue on the headstock nut, a hard plastic piece that spaces the strings evenly. Next comes the saddle, then the bridge pins which lock the strings in the bridge. Finally, they string the guitar using an electric winder. Because of all the glue drying time, it takes 3 weeks to make a guitar. The wood will become suppler the more the guitar is played, so as the guitar ages, the better it will sound. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net.